We're going to look at some rational inequalities. When we do a rational inequality, the steps are very similar to a polynomial inequality. We have to be sure that the comparison is with 0. We find the zeros and any restrictions on the variable. That's where things get a little bit different. Remember that restrictions on the variable result graphically in a vertical asymptote. So on a number line, that will always have an open circle and will be written in interval notation with parentheses because we cannot ever get to that restriction. We will put the zeros and the restrictions on the number line with the appropriate open or closed circle. Again, restrictions will always be open circle. Open circle is less than or greater than and results in parentheses in your interval notation. The closed circle occurs for greater than, equal to, less than, equal to, and uses brackets in your interval notation. Next, we will look for the sign of the function in the intervals that we get resulting from the zeros and the restrictions. And then we will look at the solution. Starting here, the first thing we need to look at is any restrictions. So we have a restriction where x cannot be a -1. And then our 0 occurs at x equals 7. So I will put both of those on my number line. Since my inequality is less than or equal to, my 7 will have a closed circle. My -1 has to have an open circle regardless of the inequality because that is a restriction. Next, we will look at these 3 intervals for the sign of the function. If we look at x equals -2, the numerator would be negative and the denominator would be negative, giving me a positive value to the left of -1. Between -1 and 7, let's look at x equals 0. The numerator would be negative, the denominator would be positive, resulting in a negative value for the function in that interval. Lastly, to the right of the 7, we could look at x equals 10 or x equals 87, right? It doesn't matter. We would have a positive numerator and a positive denominator, resulting in a positive function. For our interval, we wanted less than or equal to, so we want negative. We would have an open circle for the -1. An open circle, a parenthesis for the -1 because it's an open circle, a bracket for the 7 because it's a closed circle. And that's the only interval that fulfills the inequality. Here, the issue we have here is that we are not comparing with 0. We need to make that happen. We would have -6 over x minus 7 minus 2 is greater than 0. Remember, when we subtract that 2, we need to get a common denominator. So we would have an x minus 7 and an x minus 7. Continuing that, -6 minus 2x plus 14 over x minus 7 greater than 0. Then we would have -2x plus 8 over x minus 7 greater than 0. And then if you factor out the -2, if you factor out the -2, we're going to end up with what? -2 times x minus 4 over x minus 7. There we go. First, looking at the restriction on the denominator, x cannot be a +7. In the numerator, looking at the zeros, the 0 we would have is x equals +4. First, let's put those values on our number line. x equals positive 7 will have an open circle because it is a restriction. X equals 4 will have an open circle because my inequality is just greater than. Before we look at the signs, I do want to point out that we have a negative 2 here. So in the numerator, I'm always going to have a negative before I start looking at those factors. Let's look to the left of 4. How about x equals 0? We have a negative for that negative 2, then a negative factor divided by a negative factor. So negative times negative is positive over negative, gives me negative in that interval. Checking between 4 and 7, x equals 5. We have a negative from the 2, then a positive and a negative in the denominator, giving me positive in that interval. Then to the right of 7, we can check 10. We have a negative from the negative 2. We would have a positive and then a positive in the denominator. So we are negative here. Writing my answer, we wanted greater than. That is just the positive area. So from 4 to 7, both have parentheses. Here we have another situation where we do not have a comparison with 0. We need to get one. X minus 7 over x plus 5 plus 3 is greater than or equal to 0. Getting that common denominator, we have an x plus 5 in both the numerator and the denominator. Continuing, we have x minus 7 plus, if I distribute, 3x plus 15 all over x plus 5 greater than or equal to 0. 4x plus 8 over x plus 5 greater than or equal to 0 as I write a 4. And then we can factor the 4 out of the numerator, leaving us with 4 times x plus 2 over x plus 5 greater than or equal to 0. First, the restriction, x cannot be a negative 5. Then the 0 in the numerator, x equals negative 2. Putting these on my number line, the negative 5 will have an open circle because it is a restriction, even though the inequality is greater than or equal to. The negative 2, though, will have a closed circle because of the inequality is greater than or equal to. The last one, we had a constant out front, but it was negative. Since we have a positive constant out front here, we can kind of ignore it. Looking to the left of negative 5 at x equals negative 6, I would have a negative over negative, giving me a negative function at that interval. Between negative 5 and negative 2, maybe x equals negative 3, we would have a negative over a positive. So my function would be negative there. I'm sorry, negative over negative is positive. What is wrong with me? To the right of negative 2, we could look at x equals 0. At 0, we would have a positive over positive, which is positive. The interval that we were looking for was greater than or equal to 0. So here, negative infinity to negative 5 with a parenthesis. Again, remember, even though this is greater than or equal to, the negative 5 has to have a parenthesis because it's a restriction. Union, and then a bracket from negative 2 to infinity. All right, let's look at this one. This one looks a little crazy. So same thing here. The issue we have is that it needs to be compared with 0. To do that, we would have 3x plus 4 over x minus 4 minus x minus 1 is less than 0. And then my common denominator would be x minus 4. I need an x minus 4 here. Let me hide. Oh, I can't hide that. Let me select this and get rid of it real quick. Sorry. So next, just keeping this up here, 3x plus 4 minus x squared minus 5x plus 4 all over x minus 4 less than 0. Remember, when you have this situation, we have to be really careful and be sure that we distribute and combine. After distributing and combining and factoring, you end up with negative x times x minus 8 over x minus 4 is less than 0. Looking at the restriction, x cannot be 4. Then zeros occur at x equals 0 and at 8. Putting those on my number line, I have a 4 that will have an open circle because it's a restriction. My 0 and my 8 both have open circles because that is a less than. Next, we need to start testing our intervals, to the left of 0 at x equals negative 2. Again, remember this factor here is a negative x, so we are going to have to watch that. My first factor there then would be positive, negative over negative, which gives me positive to the left of 0. Between 0 and 4, x equals 2, we would have a negative factor, and a negative factor, giving me negative in that interval. Between 4 and 8, x equals 5, we would have a negative, positive over positive. Is that right? Negative. No, it's negative, negative over positive, sorry. I knew something was happening. That is positive. Then to the right of 8, how about 10? We would have negative, positive over positive, negative. Then putting in my interval, we wanted to know less than 0. So here, from 0 to 4, union 8 to infinity. I hope you found this helpful.